Let's evaluate the definite integral from 0 to pi over 2 of sine cubed of x over sine cubed of x plus cosine cubed of x. We'll use the following three results. The first one, the integral from 0 to a of f of x is equal to the integral from 0 to a of f of a minus x. The second result is the trig identity. Cosine of x equals sine of pi over 2 minus x. And then the third result is also a trig identity. Sine of x is equal to cosine of pi over 2 minus x. Before we start evaluating this integral, let's look at this first result and derive it. And we'll start with the integral on the right, 0 to a of f of a minus x dx. We'll make a substitution. U equals a minus x. A is a constant, so du is equal to minus dx, or minus du equals to dx. Note that in this integral, the limits of integration for variable x are from 0 to a, but u equals a minus x, so when x equals to 0, u equals to a, and when x equals a, u equals to 0. So the integral in variable u is going to run from a to 0. And now replace the variable x in that integral with variable u. We have equivalent integral, which is from a to 0, f of u times minus du, and minus comes out, so this is minus the integral from a to 0, f of u du. To reverse the order of integration, we're going to need a minus sign, and so minus integral from a to 0 f of u du is equal to the integral from 0 to a of f of u du, and u is just a dummy variable. It's integrated out, and we can replace it with variable t or y or x, and so this is equivalent to integral from 0 to a of f of x dx. And that's result number 1. Now we can return to the integral. We'll start with this integral 0 to pi over 2 sine cubed x divided by sine cubed of x plus cosine cubed of x. And by result number 1, since a is equal to pi over 2, this is equivalent to the integral from 0 to pi over 2 sine cubed of pi over 2 minus x divided by sine cubed of pi over 2 minus x plus cosine cubed of pi over 2 minus x. Now let's use results 2 and 3. Sine of pi over 2 minus x is cosine of x, and cosine of pi over 2 minus x is sine. So this is equal to, we can now express this as the integral from 0 to pi over 2 cosine cubed of x divided by cosine cubed of x plus sine cubed of x. Now when you look at this integral, it appears every bit as difficult as the original one, and that is true. However, let's look at the following. Let's take twice the original integral, so 2 times the integral from 0 to pi over 2 of sine cubed x divided by sine cubed x plus cosine cubed x. Now we'll express it as, first we'll take this integral 0 to pi over 2 sine cubed x divided by sine cubed x plus cosine cubed x, and then we'll add itself to it. But when we add another integral like this, we'll add what the equivalent integral is to it, in which we just showed. That's the integral from 0 to pi over 2 of cosine cubed x divided by cosine cubed x plus sine cubed x. And notice that these two integrals have the same denominator, therefore we can add them and form a single integral. That's the integral from 0 to pi over 2. The numerator is sine cubed x plus cosine cubed x, and the denominator is the very same thing, sine cubed x plus cosine cubed x. And of course that's 1. So the resulting integral is just the integral from 0 to pi over 2 of 1 dx. And of course that's the x evaluated from 0 to pi over 2, which is equal to pi over 2. So let's go back and look at what we just verified, or what we just showed. Twice the integral from 0 to pi over 2 of sine cubed x over sine cubed x plus cosine cubed x is equal to pi over 2. Therefore, the integral that we wanted to evaluate, the integral from 0 to pi over 2 of sine cubed x over sine cubed x plus cosine cubed x, is equal to pi over 2 divided by 2, which is our final answer, which is pi over 4. And that's the answer. For more videos,